All right, so today we're talking about lesson 12.6, which is analyzing the lines of fit. Yesterday we learned how to draw a line of fit by hand. There are also ways that you can do the line of fit with a graphing device. So if you put in the tables into a graphing calculator, they will give you out this image. And they tell you what the slope and the y-intercept is. And then they also give you this thing called R, the correlation coefficient. So we're going to come to that in just a minute. But we want to determine whether or not those lines of fits are good. So if you look at your notes from yesterday for 12.5, and you see that we had some points above the line, some points below the line, we want to know how far away from the line are these points. So this distance right here, above, this one's on the line, here and here, is our residuals. And we can have positive residuals if it's above, or negative residuals if it's below. So residual is the difference between the point, which is the actual data point, and the line, which is the predicted value. So if it's positive, then we have the point above the line, and negative, the point is below the line, and 0 is the point's actually on the line. So yesterday we did an example where we looked at the sales in millions. So if you look at that table again, then we can add 2 more columns, which is going to be our predicted column. And we're going to use the x values to solve for a new y value. So I'm going to plug in 1 and solve. So what do I get? Negative 2 times 1 is negative 2, plus 20 is 18. If I do that for this one, I'm plugging in my x, and that would be negative 4 plus 20 is 16. And notice I'm just going down by negative 2. So this would be 14, 12, 10, 8, 6, and 4. So then, to figure out how far that is from the line, we're going to calculate the residuals, which is the actual minus the predicted. Okay, so our actual values, those are here, and our predicted values are the ones that we did in red. So if we take 19 and we subtract 18, we get 1. 15 minus 16 is negative 1. 13 minus 14 is negative 1. 11 minus 12 is negative 1. That minus that is 0, 0, 1, 1. Okay? And then I'm going to graph this using the x values and the residual values. So we're going to plot the residuals and our x's. So our x's go from 1 to 8, so I'm going to start my line here, and my residuals go from negative 1 to 1. So I'm just going to graph it like this. So we've got 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put positive 1 up here and negative 1 down below. And if we put our points, then we have, when x is 1, our residual is 1, meaning it's 1 away from the line. And then we have a negative 1, another negative 1, another negative 1, 0, 0, positive 1, and positive 1. So the points that are above the line are these 3. The points that are below the line are these 3. And then these 2 are the ones that are on the line. When we're talking about whether or not this is a good line of fit, we want to look for 2 things. Excuse the announcement. We want points above and below the x-axis, and that is basically as if this is our line on the graph, on the scatter plot. So that's why we want above and below the x-axis. And then we also want no trend between the points. Okay, so it'll be a little bit more obvious than the other ones, but there's no correlation between these points. I couldn't draw a line or a shape or anything like that. Okay, so let's do one more. And so now we're looking at age and salary in Y, and then we're using this predicted value here, and then the residual. So if I use a calculator to plug this in, then I get 45, 45.4, and again I'm using my x values to plug in, and then we get 46.2, 46.6, 47, 47.4, 48.6, and 49. Okay, so this is my actual salary, and this is my predicted salary based off of my linear equation they gave us. So to calculate this, we want to do 42 minus 45 is negative 3. That minus that is negative 1.4, 0.8, 3.4, 5. And you are more than welcome to use a calculator for this. 3.6. I went ahead and did the number crunching. And then negative 4. Okay. So we want to look and say, okay, well, I'm still going to be graphing my age, the x, and my residuals. So my residuals go from negative 4 up to 5, and my age goes from 35 to 55. So instead of counting by like a ridiculous amount of numbers, I'm just going to do this thing, and that allows me to skip numbers. So I'm just going to start at 35 and then count by 2s. So we'll go 35 and then 37, 39, 41, 43, 44, or sorry, 45, 47, might need a longer line, 49, 51, 53, 55. Okay, my residuals go up to 5, 1, 2, 3, 4, down to 4. Okay. All right, so we want to plot the points where it's 35, negative 3. So that would be 35, negative 3 down here. And then we have 37 and negative 1.4. So that's here. And then we have 41 and 0.8. And then we have 43 and 3.4. And then we have 45 and 5. 47 and 3.6. Skip a little bit, go over to 53, and then that's 53, has a residual of 0.4. And 55 has a residual of negative 4. Okay, so out of all the points, all of the ones up here are above the line, and all of these 3 are below the line. These 2 are the ones closest to the actual line. So, but these actually have like a trend, like they go up and then they go back down. It's not necessarily U-shape, it's more V-shape. So, but because there's a trend, this is actually not a good fit. Even though we have points above the x-axis and below the x-axis, there's a trend here which prevents it from being a good fit. Okay. All right. Now we're going to talk about this thing called correlation coefficient. And it's this range of values between -1 and 1. Got 0 in the middle, and that tells us how well, and it's an R value, and it's how well the line describes the data. Okay, so the slope of the line is broken down into negative or positive. Okay, so we have a negative slope, or a positive slope. And the strong sides are on the ends, and the weaker ones are towards the middle. Okay? Stronger on the end. So what that means is if we looked at a graph that had -1, it means that they're all in a straight line with a negative slope. A slightly less obvious one would be they're all going down this way, but they're not all in a straight line. So that would be like an R coefficient or a correlation coefficient of 0.7. It's pretty positive, negative 0.7. It's pretty obvious what the trend is, but it's going down. And so for positive, we could do 0.5. Okay, they're pretty spread out, but you can see that they're still going up. And if something is a correlation coefficient of +1, then they are all in a straight line with a positive slope. Last but not least is correlation versus causation. So when something has a correlation, there's an obvious connection or relationship. But a causation is when there's a cause and effect relationship. Meaning there's a direct impact from one to the other. So if I wanted to compare minutes I exercise to calories burned, the more I exercise, I immediately impact the calories I burn. Whereas, and that also has a correlation, okay, but it's more specifically a causation. So something that is correlated but not necessarily direct impact is the number of banks in a city compared to the population. Okay? It's not directly impacted that if I add banks, then I automatically add population. So that's why it's a correlation, not a causation. And again, this is a one-way street. A causation automatically has a relationship, a correlation, but it's not necessarily the other way around. That's it for today. Let me know if you have questions when you come to class.